Hello everyone. Here is a question of sampling distribution given by Dipankar and Aniket. The question is the random variable x is normally distributed with mean 68 cm and standard deviation 2.5 cm. What should be the size of the sample whose mean shall not differ from the population mean by more than 1 cm with probability 0.95? Given that area under standard normal curve to the right of the ordinate at 1.96 is 0.025. Before going to the solution of the question, let's see one theorem. The theorem states that let x bar be the sample mean of a sample of size n drawn at random from a population which is normally distributed with mean mu and standard deviation sigma. Then the sampling distribution of x bar is normally distributed with mean mu and standard deviation sigma by root over n. In the question it is given random variable x is normally distributed with mean 68 cm and standard deviation 2.5 cm. X is normally distributed with mean 68 and standard deviation sigma as 2.5. Now let us take the mean of sample as x bar. According to the theorem, x bar will be n mu sigma by root over n. In the question it is given that the probability of x bar less equals to mu plus 1 greater equals to mu minus 1 as 0.95. Let's check. We have to find the size of the sample such that it shall not differ from the population mean by more than 1 cm with probability 0.95. The population mean is mu and the sample mean is x bar. So x bar should not differ from the population mean by 1 centimeter. So x bar lies between mu minus 1 to mu plus 1 and the probability value of x bar which lies between mu minus 1 to mu plus 1 is equal to 0.95. It is given in the question. Now let us convert it in standard normal distribution. Then we'll have probability of minus 1 less equals to x bar minus mu less equals to plus 1 which is equals to 0.95. Now let us divide by x bar minus mu by sigma by root over n. Divide by the standard deviation of the sample. Then we have to divide this one also. So it will be root n by sigma and this side it will be minus root n by sigma equal 0.95. Now this part taken as the variate z and it lies between minus root over n by sigma to plus root over n by sigma which is equal 0.95. Now this part, the probability of this part we can write as 1 minus twice probability of z greater equals to root over n by sigma as 0.95. So twice probability z greater equals to root over n by sigma is 1 minus 0.95. Probability of z greater equals to root over n by sigma is 1 minus 0.95 by 2, that is 0.025. Now look in the question that the area under standard normal curve to the right of the ordinate at 1.96 is 0.025. Here in the diagram you see that at the right of z equals to 1.96 under the curve the area is 0.025. So z is 1.96, which imply root over n by sigma equals to 1.96. N equals to 1.96 whole square multiplied by 2.5 whole square. Sigma value is 2.5 given in the question. Here n equals to 24.01. Therefore, n is 25. Hope all of you have understood. In the next lecture, we'll discuss another problem of sampling distribution.